All right, dear Math for College, we've already looked at these notes, so go ahead and move along to this section where we talk about multiplying and dividing radicals. And just a nice review here, you should keep in your mind what the perfect squares are. And just to let you know, this Unit 4, um, so Unit 4, which we're in, and then Unit 5, those actually together all used to be in Unit 4. What I've done is I've separated them because that way we're looking at smaller amounts of material. Hopefully, make the test easier. But it when we start dealing with radicals and fractions and stuff like that, that proves to be difficult for a lot of students. So I'm trying to break this up a little bit better for y'all and trying to add a little bit of review. So you should keep in mind the perfect squares, like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, and 16 squared is 256. And as we review our simplifying of radicals, maybe you remember that when we were adding and subtracting, the radicands had to be the same. In this situation, 7 is the radicand. It's underneath the square root sign. So I just get negative 3 roots of 7. Whereas in this situation, they are not the same. And so we have to simplify our radicals. So we have 3 roots of, what is the perfect square that divides evenly into 18? And it is 9 times 2. Plus 4 times, now you have the square root of what divides evenly into 50? That would be 25 times 2. And look at that. We came up with 2 in both situations. So we know we're going to be able to add these guys together. The square root of 9 is 3 times 3 is 9. So we have 9 roots of 2 plus, and the square root of 25 is 5 times 4 is 20 roots of 2. And so now you can add them together, and we get 29 roots of 2. So this is a really key problem right here. This is one you really want to be able to know that kind of a problem for the test because it involves adding and the simplifying process. So let's talk more about simplifying radicals today. We're going to be looking at fractions. In order for a radical to be simplified, it must have all perfect squares removed and no radicals in the denominator. Actually, what would be better to say is rationalized denominator. And what a rationalized denominator means is simply this. Um, 3 is a rational number because you can express as a fraction, say 3 over 1 or 12 over 4. And then there's irrational numbers. Irrational numbers would be like pi because it goes on forever and doesn't repeat itself. Square root of 2. Let's talk about the square root of 2. If you have the square root of 2 in the denominator, we say that the denominator is not a rational number. You need to make it a rational number. If we just multiply the top and bottom by the root of 2, you see we get 3 roots of 2 over 2. And so that skill is one that we're going to use as we venture into this, okay? Simplifying the following radicals. Turns out that with radicals, you can take the square fraction, you can take the square root of the top and the square root of the bottom. And so you can see here you get 2 over 3. And here you get the square root of 25 over the square root of 49. And so you can get 5 over 7. You have to write it out every time. You can see in this situation, you get 1 on the top and 16 on the bottom. And in this situation, we don't have a square root of 6, but the square root of 25 is 5. We can leave it like that because, again, you don't have a square root in the denominator. In this case, negative root of 2 over square root of 49 is 7. In this case, the square root of 7 over square root of 100 is 10. So those are all okay because you can see in the denominator, you don't have the square root of a number that can't be simplified like that. So let's look at this example, okay? Square root of 2 over 3 would be written like this. Now, you can't leave it like that because you have the square root of 3 in the denominator. If I multiply the top and bottom by that square root of 3, look at what happens. In the top, I get the square root of 6, and the bottom, you get the square root of 9. Now, I'm not ever really going to write the square root of 9 because you know that the square root of 9 is 3. Is that nice? Square root of 3 times square root of 3 just becomes 3. Look at the next one. We multiply top and bottom by the square root of 2. And we get the square root of 10 over 2. In the next situation, we multiply the top and bottom by the square root of 6. And we get the square root of 18 over 6. You might say, well, I'm done. You're not done because you can simplify the square root of 18. See, the square root of 18 is the square root of 9 times the square root of 2 all over 6. The square root of 9 is 3. So I have 3 roots of 2 over 6. And finally, you know that you can simplify the 3 over 6 to 1 square root of 2 over 2. That's your result. So yeah, sometimes these can get a little bit more involved. Look at example 10. I multiply top and bottom by the root of 3. And I get 6 roots of 30 over 3. Square root of 30 can't be simplified, but 6 over 3, that would be 2 roots of 30. We're going to skip 12, but do 11. Multiply top and bottom by the square root of 2. And notice you get 8 roots of 14 over 2. 4 roots of 14. So there we go. A nice just kind of simplifying of radicals, rationalizing the denominator, remembering to multiply and divide in certain situations. And there you go. So hopefully that's a nice little review. Nice short video for you. And we'll see you in class.